Question 1. It is desired to send a sequence of computer screen images over an optical fiber. The screen is 3840 into 2160 pixels, each pixel being 24 bits. There are 60 screens images per second. What data rate is needed? Answer. Given screen resolution is pixels, bits per pixel is bits, and the frame rate is images per second. In step 1, we need to calculate pixels per frame, and in step 2, we need to calculate bits per frame, and in third step, we need to calculate bits per second. After converting it to Gbps, the required data rate is approximately 11.94 Gbps, about 12 Gbps. Question 2. Television channels are 6 MHz wide. How many bits per second can be sent if 4-level digital signals are used? Assume a noiseless channel. To find the maximum data transmission rate over a noiseless channel, we use the Nyquist theorem, which states the maximum data rate. Given bandwidth B equal to 6 MHz and number of signal levels M equal to 4. First, we need to calculate log m to the base 2 and substitute the values into Nyquist formula. Therefore, the maximum number of bits per second that can be transmitted over a 6 MHz television channel using 4-level digital signals in a noiseless channel is 24 bits per second. Question 3. If a binary signal is sent over a 3 kHz channel whose signal to noise ratio is 20 dB, what is the maximum achievable data rate? The maximum achievable data rate of a channel is given by Shannon's capacity formula C equals to B log of 1 plus SNR to the base 2. Here SNR is the signal to noise ratio. Given bandwidth B equal to 3 kHz and SNR in decibels is 20 dB. Converting SNR from decibels to linear scale, it is 100. Substituting in Shannon's formula, we get C equals to 19,984 bps, and the maximum achievable data rate is approximately 20 kbps. Fourth question. 10 signals, each requiring 4000 Hz, are multiplexing onto a signal channel using FDM. What is the minimum bandwidth required for the multiplexed channel? Assume that the guard band is 400 Hz wide. Answer. In FDM, minimum total bandwidth required for multiplexing n signals is the sum of individual signal bandwidth plus the sum of the guard bands between adjacent channels. Here given number of signals, bandwidth per signal, guard bandwidth, number of guard bands. And if guard bands were also required at the channel edges, add 2 more guard bands with edge guard. The total would be 10 into 4000 plus 11 into 400, that is 44,400 Hz. Question 5. Why has the PCM sampling time been set at 125 microseconds? Answer. In pulse code modulation PCM, the voice signal is band limited to 4 kHz. According to Nyquist sampling theorem, the sampling rate must be at least twice the highest frequency, that is Fs equals to 8 kHz. This means that the signal must be sampling 8,000 times per second. The time interval between two successive samples is 125 nu. Hence, the PCM sampling time has been standardized as 125 microseconds in telephony systems. This ensures that all voice frequencies up to 4 kHz are represented without loss, and also provides uniformity for multiplexing and switching in digital communication networks. Sixth question. What signal to noise ratio is needed to put a T1 carrier on a 1 MHz line? The capacity of a channel is given by Shannon's theorem C equals to B log of 1 plus SNR to the base 2. For T1 carriers, C equal to 1.544 Mbps and B equal to 1 MHz and SNR equals to 1.91. Converting into decibels, SNR equals to 2.8 decibels. The minimum signal to noise ratio required to put a T1 carrier on a 1 MHz line is 2.8 decibels. Seventh question. A cable TV system has 100 commercial channels, all of them alternating programs with advertising. Is more like TDM or like FDM? Answer: a cable TV system with 100 commercial channels uses different frequencies to carry each channel simultaneously over the same cable. So this technique is called frequency distribution multiplexing (FDM) because multiple signals share the channel by occupying different frequency slots at the same time. The system is more like FDM than TDM since each TV channel is carried on a separate frequency band. Eighth question: a cable company decides to provide internet access over cable in a neighborhood consisting of 5,000 houses. The company uses a coaxial cable and spectrum allocation allowing 100 Mbps downstream bandwidth per cable. To attract customers, the company decides to guarantee at least 2 Mbps downstream bandwidth to each house at any time. Describe what the cable company needs to do provide this guarantee. Each house must be guaranteed to 2 Mbps. For n equal to 5,000 houses, the total guaranteed downstream capacity required is C required equal to n into 2 Mbps, that is 10 Gbps. But the available downstream bandwidth per cable is only per 100 Mbps. So, in first step, we need to divide the neighborhood into smaller service groups. Node splitting houses per cable is 50, and provide additional physical capacity or spectrum. And next, we need to deploy hybrid fiber coax HFC and split the nodes, that is fiber deeper. Push the fiber closer to the customer and split the coax plant so each coax node has few homes. This is common practice in cable plant upgrades. Next, use modern DOCSIS provisioning and QoS. Implement the static reservations or minimum rate classes on the CMTs to enforce the guarantee. Next, consider replacing coax with fiber FTTX if guaranteed service is strict. And next, operational considerations. Additional headrooms about 10 Gbps should be provisioned per peak burst, control traffic and further future growth. A single 100 Mbps cable cannot guarantee 2 Mbps to 5,000 houses. To provide the guarantee to operate must split the network into many smaller services groups or increase the aggregate capacity and use provisioning to enforce the per subscriber 2 Mbps guarantee.